Fiber reinforced plastic is a composite material made of a polymer matrix reinforced with fiber. So in this case, we have fibers and polymer matrix. So when we combine these two, we get a composite material which is termed as fiber reinforced polymer. So here the quote, united you stand, divided you fall comes true. These fibers, when these are not mixed with the matrix or resins or polymer, so these will not resist any load. Their resistance or their strength will be minimum. But when we unite these fibers with the help of this polymer matrix, their strength will increase sufficiently. So just by combining these fibers to act as a unit member, so their strength can be enhanced. So here we can see these are the fibers and the matrix. And one thing to note about the fibers, so they are strong along the direction of fibers. So whatsoever is the direction of fibers, so they are strong in that direction, in tension especially. Okay, if we talk about the constituent, so we have two main constituent, fibers and polymers. So different type of fibers are available in the market. For example, glass fibers, carbon fibers, aramid fibers, basalt fibers. Similarly, there are many type of polymers available in the market. For example, epoxy resin, vinyl ester resin, polyester resin, and phenolic resin. So some of these resins are thermoset and some of them are thermoplastic. Okay, next let's discuss about the properties of fiber reinforced polymers. So first we will discuss its positive properties, or the properties which can be considered positive. So it has high strength to weight ratio, especially its tensile strength is significantly high. So if we compare it with the reinforcing steel has strength about 420 megapascal, the yield strength, but the strength of CFRP or the fiber reinforced polymer can go up to 2500 megapascal. So it is significantly higher than that of steel. So it is lightweight, so the weight of FRP as compared to steel is 75% less weight. So they have high stiffness and their stiffness is comparable to steel, especially in case of CFRP. If we see the slope of this line, so they are having stiffness equal or equivalent to that of reinforcing steel. So they are electrical insulators. So electricity cannot pass through these polymer matrix or these FRPs, especially in case of glass fiber reinforced polymers. So these are excellent corrosion resistance. There is no issue of corrosion in case of FRPs. They are good chemical resistant. They are dimensionally stable. The change in the temperature will not affect their dimensions. This is a durable material, mean its service life is significantly long. Low moisture absorption as well as low heat conductivity. So these are the positive properties of fiber reinforced polymer that can be used for different type of usage in the construction industry. So next we can discuss some negative aspects of the fiber reinforced polymer. For example, they have high manufacturing cost. Manufacturing in a sense that the fibers as well as the polymers, so their construction is difficult and it is very costly. And they are brittle material. So they are elastic up to their failure point and then they fail in a brittle manner. There is no yielding in case of fiber reinforced polymers. So they have low compressive and shear strength. So as I said earlier that their strength is more in the direction of fibers, but perpendicular to that or in any other direction their strength will be less. So under compression as well as under shear, these FRPs are not that strong as they are strong in the tension. And one more drawback or disadvantage of this FRP is their matrix degrade due to ultraviolet radiation. So this is a durable material, but only problem is their matrix can degrade due to the ultraviolet radiations. Okay, next, let's discuss about the manufacturing of fiber reinforced polymer. Then we will take a short break and we will discuss if we have some questions related to that. Okay, so there are many methods to manufacture different products out of the fiber reinforced polymers. So the first very cheap and very easy method is hand layup method. In this method, what we will do, we take a mold and then we apply a gel so that the matrix could not stick with the mold, and then we spread the resin over on that mold. And then the fibers or the fiber sheet is spread over this mold and it is pressed with the help of roller so that this sheet could be completely saturated with the resin. So after the polymerization of the resin is complete, we can demold this product and we can have our required product. So we can see over here, so we can construct many or any type or any shape out of this technique. So here this is a mold and then this sheet is laid and then the matrix is applied or the resin is applied over that, and that is compressed with the help of roller so that this sheet should be uniformly saturated with the resin. So any type of product can be made by using this hand layup technique. Next is spray molding. So it is similar to that of hand layup. In hand layup we use the mold and the gel and then we spread the fiber sheet, but here instead of fiber sheet we use the discrete fiber. So we spray the fibers as well as resin on this mold to form our required thickness of the product. So here we can see mold and we can spray the resin as well as the fibers on this mold, and finally we can get such type of products. So most of the sheets that we use in the construction industry for the doors, for the grills, so these are made by using this technique. In that case we use the discrete fibers, so we can spray and spread the fibers equally on all the area. So the next method is wet compression molding. So in that case we take the fibers or fabrics made by these fibers. We have fiber sheets, woven fiber sheets. So we impregnate with the epoxy resin and then this pre-preg or impregnated sheet can be laid in different directions so that the strength of the material or the product should be equal in all directions. So after laying these pre-preg, we can place it in the mold and compress. So after the polymerization of the resin is complete, we can demold and we can get our required product. So this method is very suitable and it is very suitable to make the automobile parts. So by using this method we can fabricate very compact and durable products. So we can see we can place the sheet and then compress to get the required product. So similarly we can also prepare the manhole covers by using this technique by with the FRP material. So the wings of the aeroplane are also fabricated by using this technique, and similarly the other parts can also of the automobiles can also be fabricated by using wet compression molding. The next method is resin transfer molding. So in case of resin transfer molding, so the assembly is almost similar to that of compression molding, but in this case instead of applying the pressure and placing the pre-preg inside this mold, what we do, we place the fiber sheet in this mold and then we inject the resin under pressure so that no cavity should be left inside this mold. So after the polymerization of the resin, we can demold. So here we can see we have a mold and the resin is injected under pressure. So after demolding, we can get very fine products by using this technique. So the next is Pultrusion process. So in this process, what we do, we take rovens. We take continuous fibers, we impregnate with the resin in the impregnation bath, and then these fibers, impregnated fibers, are passed to the preformer. So here we have a die, a preformer die, which arrange the fibers in the required shape, and then these preformed fibers are passed through the polymerization chamber, where we have a control temperature and we have dye to give the final shape to the product. And then this final product is pulled out of this assembly by using this caterpillar. So because of this pulling and fabrication process, we term it as a Pultrusion process. So you pull the impregnated rovens through the dye, and ultimately we get our required product. So any type of product or any shape can be possible by using this method. So we can fabricate all type of structural shape just like steel structure for the construction purposes. So we can see here we can construct W section, pipes, channel section, I section, box section. So any type of section is possible. We can also fabricate this type of connection by using this technique, and this type of connection are used for prefabricated structure. We can also produce or fabricate the reinforcing bar. So similar to the steel reinforcing bar, we can also fabricate the bars by using this technique for FRP material. So these bars have sufficiently high strength, or its strength is significantly high if we say compared to the steel, their tensile strength. The last technique is filament winding. So in filament winding, what we do, we take the rovens or the continuous fibers of, for example, carbon fiber or glass fiber, then we pass it through the impregnation bath. We impregnate these fibers with the resin, and then these fibers are wound on the rotating mandrel. So we have a steel mandrel and these fibers are wound on that rotating mandrel. So ultimately we can get our required shape. So here we can see these fibers are impregnated in this bath, impregnation bath, and then these are wound on this mandrel, this rotating tube. So by using this technique, we can fabricate the pipes, we can also fabricate the pressure vessels. So we can also fabricate the wagons of the train. So by winding the fibers, continuously winding the fibers on the mold, and then after demolding, we can make these holes by cutting the fibers. So in this way, we can make this bogie as a single unit.